Good evening, my YouTube viewers. In this particular video, what we're going to be talking about is contingency coefficients, which is a measure of association. So contingency coefficients are used to measure the strength of association in contingency tables. And so what we're going to do is we're going to create a program in Python to prove contingency coefficients. So the first thing that we do is we're going to import the libraries that we're going to need to import to execute the program that we're going to make. So the first library that we're going to import is NumPy as NP, which is a numerical library that creates NumPy arrays and distributions and performs numerical computations. And then from scipy.stats, we're going to import chi-square2 contingency. So scipy is Python's scientific library, and stats is a statistical module within scipy, and chi-square2 contingency is one of the tests that we're going to perform. So what we're going to do after we have imported our libraries is we're going to create a contingency table. So the rows represent one categorical value and the columns represent another. So data equals np.array, and then you have three lists, so which are three rows of 50, 30, 20 is first row, 30, 50, 20 is the second row, and 20, 20, 60 is the third row. And then what we're going to do is we're going to perform the chi-square test. So chi-square stat, comma, p-value, comma, DOF, comma, expected frequencies equals chi-square contingency data. So chi-square stat is like a test statistic. P-value is a probability. A DOF is your degree of frequency. And expected frequencies is what you're going to expect to get out of it. So we're going to calculate the contingency coefficient. So n equals data.sum. Contingency coefficient equals np.square root brackets chi-square stat divided by chi-square stat plus n. And then we're going to display the results. So we're going to display the observed frequencies, the chi-square statistic, the degree of freedom, the p-value, and the contingency coefficient. So our observed frequencies are what we discussed is 50, 30, 20, 30, 50, 20, and 20, 20, 60. And the expected frequencies are what you would get in the chi-square test for independence. And I think that when we did it in a previous video, all of the values, the rows and columns, were I think 33.33 for each of them. So your chi-square statistic is 60, your degree of freedom is 4, and your p-value is 2.9 to the negative 12. And so the p-value is definitely less than the null hypothesis of 0.05. So that means you'll have to go with the alternate hypothesis. So the null hypothesis would be there's no significant difference between the observed values and the expected values. And the alternate hypothesis is there is a significant difference between the observed values and the expected values. And then since the p-value is less than 0.05, you're going to have to go with the alternate hypothesis, which means the expected frequencies are significantly different from the observed frequencies. And then so the contingency coefficient is 0.4, and so the strength of the association is moderate. And so basically we're going to interpret the contingency coefficient because the contingency coefficient is anywhere from 0 to 1. So if the contingency coefficient is less than 0.1, the strength of the association is negligible. If it's less than 0.3, the strength of the association is weak. Else, if it's less than 0.5, the strength of the association is moderate, or else the strength of the association is strong. And since the contingency coefficient is 0.4 and it is between 0.3 and 0.5, then the strength of the association is moderate. So that concludes this video. And the next video, we'll be talking about another measure of association. And so I hope that you decide to watch it.